Welcome to day 5 of Advent of Code. I'm really excited to dive into this new challenge. Today we have some list of characters that represent a specific position in a plane. And one thing that's really important is to take a bit of time today to really understand how this is formatted. Because if you understand the format of this, it will be a lot quicker to code. And I've spent a bit of time before the video trying to understand what's happening. And there are 7 characters, I believe. There's a bunch of characters. Yeah, 7 characters that are indicating the row, if I'm correct, yes. And 3 characters that are indicating the column in the plane. And what you can see is that there is something a bit complex where they say, okay, you start by considering the whole range, row 0 to 127, F means the lower half, while B would have mean the upper half. And if you spend a bit of time on that, it will just, the solution will jump to your eyes, which is that you need to use to convert this from a binary number to a decimal number. So basically, this is what we're going to do right away. This is the usual code that I use at the beginning. We're just going to paste this format to remember, and we're going to create a class seat. Let's call that a seat in a plane. For reference, I'm using classes because I'm thinking that at some point they might want to move from to reuse this for another challenge. So I'm always using classes now, trying to make code that is kind of clean so that I can reuse it later down the road. Right away, we're gonna say const row is equal to string that slice 0 to 7, and then const column is equal to string that slice 0 to 7 as well. I think we're actually gonna convert that into, so we're gonna convert that into an array. I don't know if I can do that in there. Let's actually do const chars string. So now I can reuse these chars here and there. I believe slice is working as well for an array. Yes, that's correct. So we're good. Oh, here we want from 7 to the end of the array. And I believe we need to apply something specific. So here we have a number, and we see that F means the lower half and B means the upper half, which means B is 1 and F is 0. So here we're going to map, and I'm going to say X. If X is equal to B, then 1, otherwise 0. That's it. That's going to convert this into an array of zeros and ones. We're going to join that then. And by joining, we are making a string of 0 and 1. And now we can do a parse int. And parse int has a specificity, which is that the first is the string and the second parameter is the radix. So here we just have to say that this is a binary string. And this is it. We should have our correct row. And we're actually going to store that directly. This dot row, we're going to store that directly into the row. And I'm going to copy paste the code. Usually it's good to not copy paste code, to not repeat yourself. But usually you start to refactor code when you have like 3 copies of your code. If you just have 2 copies of your code, it's fine. It is fine. And here, what I'm looking for is that R mean 1s and L mean 0. So here I just have to have R. Actually, you know what? I think we need to convert that. So we're going to have a little helper is here, string to int. And here you know what, we're actually gonna split the string here, and we're gonna do all of these things. Return, because yeah, actually I want to have cleaner code. So if x is equal to b or x is equal to r, then we have 1, otherwise we have 0. We join and we pass as a binary number, which means that we can write a lot cleaner code here, which is nice. Actually, let's take string to int here. Yes, and we can remove this. Yeah, actually, usually I don't mind copy pasting code, but here you can really see that it feels a lot nicer already. Code looks a lot nicer. We have like all of the complex handling in one function, and here we're just using this function. We can store also right away this dot ID, which I believe is the last thing that we need, the seed ID. And the seed ID is computed with a little formula, which is multiply the row by 8 and add the column. So ID is equal to this dot row times 8 plus this dot column. I believe this is everything we need. Now we just need to reuse our inputs. And we're gonna do like usually, like just lines that we're actually gonna do for of, you know, I like that line of lines. I'm gonna say const s equal new seed of line, and here we're gonna console log s. Actually, we're gonna console log, yeah, the whole seed. And we're gonna copy paste these 3 inputs into our test, because it's always good to do like this kind of unit tests. Okay, that's it. I can save and I can run that. Oop, day 05.js. We have row 77. Yes, that looks really correct. 74. Yes, this is correct. So we can go ahead and get the full input here. Maybe someday in the future I'll do something to not have to copy paste manually the inputs. I know the best players do that, but you know what? For now, it's fine. Actually, we want the highest seed ID on a boarding pass. So we're just gonna store this const seeds. I'm gonna just do seeds. I'm gonna push s. And I'm gonna say const. We're gonna just log seeds. We're gonna map from a seed. We're gonna map the seed.id. And we actually want to get the maximum of that. Math.max. And using these 3 dots spreads all of these IDs into arguments that are passed to the max function. I forgot to save, which is a typical mistake that I do. Maybe I need to enable the autosave. Okay, this one, let's see. Yes, that's good. We've got our part 1 in the bag. Let's do part 2. Oh, now we're in a plane. We have fasten seat belt. It's a full flight. So the seat is the only missing boarding pass in the list. Some of the seats at the very front and back of the plane don't exist on this aircraft. They'll be missing from the list as well. Your seat wasn't at the very front or back, though. The seats with IDs +1 and -1 from yours will be in your list. Okay, so basically we have to go through each of these seat IDs. And what do we need to return? We need to return the ID. Okay, so we don't care anymore about the rows and columns in here. So here we're gonna save this const. Oops. Const Oh, IDs, this is it, and here we have to put our IDs back for the first part of the challenge. And now for the second part of the challenge, we need to find a missing ID. So we're going to do IDs.sort, and we're going to say, we're going to go through each of these IDs actually. We're going to do for loop, that's it. Each of these IDs, and we're going to check if IDs of I minus 1 so it needs to I need to check between the current ID and the next one, and there needs to be an empty. They need to be not consecutive. So if IDs of I plus 1, so here when we do that, we need to make sure here we do minus 1 to not go over the array, over the end of the array. If the difference between two IDs that should be consecutive is more than 1, in that case we just have to console log this, I believe. We should be good. We can even use a little break here so that we don't go through the rest of the forks in the plane. Let's see, 12. So I think what would be best would be to also display here log the first IDs. Let's see. Okay, so I've got an issue, which is the sorting did not work. The sorting did a lexical sorting while we should have done an integer sorting. And for that, I want to sort from the smallest to the biggest. So let's see. Now you can see that this is the correct sorting, and I have a much different number. You know what? I think this looks good, so we're gonna try that. Let's do a last run. Is that the seat that we're gonna be sitting in? Yes, it is! Thank you very much for today. I think this was quite of a fast one. Anyway, feel free to drop a like, a follow, a subscribe, sorry, and a little comment. That helps a ton. Thank you very much for the support in this series, and feel free to watch the next one tomorrow when it is released. Bye bye!